Alright students, this session is very important if you talk about your permutation and combination topic, because in this session we are going to attempt your past paper question, right? It's your exercise 10.5, which comprises on all the past paper question. On your screen, the question you can observe, it's from past paper 1-1, alright, June 2014. You can observe that. Now all the things we had discussed about the topic permutation and combination, you need to apply all those conditions, all those strategies on the past paper question, right? In the first part it says, how many even numbers less than 500 can be formed using the digits 1, 2, 3, 4 and 5. Each digit may be used once in any number, alright, and it has a weightage of 4 marks, as you can see here, right? So numbers we are looking for 500, that means we are looking for 3-digit numbers, but the condition is that it must be even, right? It must be even and lesser than 500, right? So if you remember that such type of questions we attempt by making these dashes, right? So we have even numbers if we have 2 at the ending or if we have 4 at the ending, right? So first I want you to give it a try by yourself, and for that part you have a time of 2 minutes. So start. Alright class, now if I observe the condition of even number first, so if at last number it will be 2, so it makes it even, or if it is 4, so it makes it even. The second condition is it must be lesser than 500, right? With respect to this condition, the first number, it cannot be 5, but other than 5 it can be any number, right? So for the first one, how many options we have? We have 1, we have 3, 4 and 5. No, not 5, right? We have 1, 3, 4. So for the first part we have 3 options here. It can be 1, it can be 3, it can be 4. So we have 3 permutation 1. Alright class, we have 3 permutation 1 because there are 3 possible outcomes and we need to pick any one of them. This 2 is not, you need to multiply by 2. It says that the one placement has been occupied by 2. Alright, now what about the last part here? So how many numbers we have? We have 1, 2, 3, 4, 5, right? And among those 5 numbers, we got 2 numbers here. Alright, among those 5 numbers that are 1, 2, 3, 4, 5, we got 2 numbers. That means the leftover part we have, it's 3. So it can be any number from the remaining 3 numbers. Alright, for the next case we have, now in this case we have 4 at last to make it an even number. Now for the first 3 numbers we can either 1, 2 or 3, so that will be 3 permutation 1, and at the center you can have 5 as well, right? So at center, out of 5, 2 numbers are occupied, that means we have 3p1. Alright class, so how you are going to write the final answer? It will be 3p1 into 3p1 plus 3p1 into 3p1. Alright, so that gives you the value of 3p1 is 3 times 3p1 is 3 plus 3p1 is 3 and 3p1 is 3. 3 3s are 9 plus 9 leads to 18. But that is not your final answer. Why? It says the number less than 500. So if I am writing the number 7, is it lesser than 500? Answer is absolutely yes, right? If I am writing 72, is it lesser than yes? Answer is it lesser than 500? So yes, it is lesser than 500, right? So that means we are not only focusing on 3-digit numbers, we need to continue with 2-digit numbers and a single-digit number as well, right? So now if we talk about the 2-digit number, there are also 2 cases because we are looking entirely on even numbers, right? So at the end either we have 2 and at the end either we have 4. So we have total 5 numbers. 1 number has been occupied, that means the remaining numbers are 4. So it can be any numbers 4 combination 1 or any number 4 combination 1 here as well. Finally we need to pick a number single digit, right? So for single digit number we also have 2 options, either it's a 2, either it's a 4, because we need to focus on the condition that it is a prime number. So it's permutation for P and it's as well for P1. Alright class, now we need to solve it. So 4P1, it's 4 times 2 is 8. No, 4 times not 2, it's only 4P1 which is 4, and 4P1 it is equals to 4. So we need to add 4 plus 4, 8 in it. And for the last one we have how many options we have? We have 2 options here. Alright, so that will be 2 as well, because it is my first option, second option for a single digit. So the total we have, it's 28. That is the final answer of this one. After that, moving on to the next one, part B. A committee of 8 people is to be chosen from 7 men and 5 women. The chosen word is a key word that we need to apply combination here. Find the number of different committee that could be selected if the committee contain at least 3 men and at least 3 women. Now we have attempted such type of question in the last class as well, that what is the meaning of at least and how we attempt such question by making cases here, right? So you need to attempt it by yourself first, and time for this part is 3 minutes, so start. Alright class, so the best way to attempt such type of question is you need to make a table, right? So for part B, how many men and women we have? So we have total 8 people, right? And out of 8 there are 7 men and 5 women. So I will make 2 column here, men and women, right? It says we need to select at least 3 men and 3 women. So let's start with this one. If I am selecting 3 men, alright, so how many women should be there? A committee of 8 people, we need to select 8 people, right? So if I have selected 3 men, that means the woman should be 5. 5 plus 3 leads to 8, right? And we cannot exceed the value greater than 5, because we have total 5 women. Now it says at least 3 men, so if I'm saying that I have 4 men, the woman should be equals to 4. If I have 5 men, woman should be equals to 3. If I have 6 men, woman should be equals to 2. And if I have 7 men, woman should be equals to 1. Alright, these are all the cases of at least 3 men. Alright class, I hope that it is clear to you. So total men we have is 7. So for the first one, I can say that it's 7 combination 3 times 5 combination 5. I can say that it's 7 combination 4 times 5 combination 4, 7 combination 5 into 5 combination 3. And the rest 2 cases I am not going to attempt these 2, because it is not following the condition of at least 3 women. So we can simplify these 3. So 7 combination 3. 7 combination 3, it's 35, right? And 5 combination 5, you know that it's 1, so it's 35 only. After that, 7 combination 4, it's 35 times 5 combination 4, it's 5. 7 combination 5, it's 21. 5 combination 3, it's 10. So what we got? 35 into 5, it's 175, and 21 into 10, it's 210. So when you add all those values, you will get the sum of 420, and that is your final answer. For next part, it says the oldest man or the oldest woman, but not both, must be included in the committee. Alright, so it means that out of 7 men, the one is the oldest one, and out of 5 women, the one is the oldest woman, right? So for second part, either the oldest man or the oldest woman, but not both. So I can say that there are total two, either the oldest man or the oldest woman, and out of these two we need to select one. Alright, now how many are left there? Alright, it was initial 7 men, but one is the oldest one which we had separated here. So now there are 10 men. Similarly, initially there were 5 women, but we have selected the oldest one, so now there are 4 women, right? So now it's 6 men and 4 women, so total there are 10. We need to make a committee of 8 people, right? Out of 8 we have selected 1, that means the leftover part is 7. Alright, now you can find it. 10 combination 7, it's 120, and 2 combination 1, it's 2, so 2 into 120, it's 240, and that is your answer. Alright, so when you have such type of cases in which the oldest man or the oldest woman or such type of scenario, so it's 2 combination 1. Alright, so I hope that it is clear to you. Moving on to the next one, it's question number 2 from the same exercise 10.5, and it says an art gallery displays 10 paintings in a row. Of these paintings, 5 are by Picasso, 4 by Monet, and 1 by Turner. Find the number of different ways the paintings can be displayed if there are no restriction. So first you need to give it a try by yourself for the first part, and you have a time of 1 minute, so start. Alright class, so for A part 1, since there are no restrictions, the answer is very simple. It's 10 factorial gives you the value of 3628800. That is the first part answer. After that, find the number of different ways the painting can be displayed if the paintings by each of the artists are kept together. That means the paintings of 5 Picasso, they need to be together. Monet, 4 paintings of Monet, they need to be together, and 1 by Turner. Alright, so the paintings need to be together. You need to give it a try by yourself, and time is 3 minutes to give it a try, and then I will tell you the answer, so start. Alright class, to attempt such type of questions, we are going to apply the same strategy that there are 10 paintings, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It says the number of paintings of each artist are kept together. So if we have 5 by Picasso, so it's 1, 2, 3, 4, 5. So these 5 are occupied by Picasso. Alright, after that it says 4 by Monet, so it's 1, 2, 3, 4 by Monet, and the last one by Turner. Alright, also we can do it in the same way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's suppose I am saying that the first 4 are occupied by Monet, right? After that we have Turner, this one, and the last 5 we have Picasso. Alright class, it is also the possibility, the first 4 by Monet, and then we have Turner, and then we have Picasso. Now there is one more possibility, that the first one is a Turner, and then we have Picasso, and then we have Monet, or the first word is a Turner, and then we have Monet, and then we have Picasso. So we have different options, right? If when talking about this one, so in this box the 5 paintings can be shuffled, right? So it's basically 5 factorial. In this box we have 4 drawings, 4 paintings that can be shuffled, so it's basically 4 factorial. And how many possibilities we have? It will be 3 factorial, right? So the final answer we can say that it will be 5 factorial for the Picasso times 4 factorial for Monet, and then we have 3 factorial, right, for the placement. I have constructed only 2 ways, so there are possibility that there are 3 factorial ways. So we can solve it, and it will be equals to 5 factorial, it's 120, times 4 factorial, 4 factorial is 24, and 3 factorial is 6. So 24 into 120 into 6 gives you the value of 17280. There are total 17280 ways in order to arrange all the paintings by the same artist together. Alright class, so that is your first part 1 and 2 has been done. Moving on to the part B. It's the same question but it's part B. A committee of 4 senior students and 2 junior students is to be selected from a group of 6 senior students and 5 junior students. Calculate the number of different committees that can be selected. Alright. So the data you have is you have 4 senior, 2 junior is to be selected from a group of 6 senior and 5 junior students. So the first part is quite simple, and the keyword here we have is selected. That means you need to apply combination here. Alright. So it's not that much difficult part, the first one especially. So you need to give it a try first, and for this part you have a time of 2.5 minutes. So start. Alright. Now we need to attempt pick 4 senior from a group of 6 senior, right? We can say that for first part it's 6 combination 4 times 5 combination 2. That is very simple because there is no condition that a specific student must be involved in the committee. So its value will be 6 combination 4, it's 15, times 5 combination 2, it's 10. 15 times 10 leads to 150. That is your first part answer. After that, calculate the number of different committees which can be selected if at most one of these cousins is included. At most means at most is the opposite of at least, right? If it says that at least 3, so we can select 3, 4, 5, 6 and so on. But if it says at most 3, so we can select either 0, 1 or 2. So at most is basically the highest value it can predict. Calculate one of the 6 senior student is a cousin of one of the 5 junior student. Now there are cousin present in this selection. So you need to attempt, so if at most one of these cousin is included. So first give it a try by yourself that what do you think the possible cases we have here, and for this part you have a time of 5 minutes. Alright, give it a try, start. Alright class. Now there are 2 possibilities, right? The one possibility is one cousin is in group. I am including one cousin here. The second one is no cousin. Alright, why is it so? Because it says at most one of these cousins, right? It means that maximum one of these cousins can be included in the answer, not both of them. So if the cousin is included, so that will be very simple. The two which are cousins, out of 2 we need to select one of them. Alright, now the leftover part we have, if it's 6 senior students, so now it won't be a 6, it will be a 5, right? And among those 5 we are not going to select 4 of them, we are going to select 3 of them because 1 we had already taken from 2 combination 1. Similarly, if you have a group of 5 junior students, so now they are not 5 here, they will be 4, and among those 4 you are not going to select 2, you are going to select 1 here. Alright, so we need to simplify it. So 2 combination 1 it's 2 into 5 combination 3 it's 10, and 4 combination 1 is 4. So 10 4s are 40 times 2 it's 80. Now the next case in which there should not be any cousin, right? So if there should not be any cousin, that means 2 persons, one from the senior and one from the junior has been eliminated, right? So if it's a group of 6 seniors, so now it won't be a 6 senior, it is 5 seniors, because one, the cousin student, has been eliminated, and among those 5 we need to select 4 senior students, right? Similarly, we don't have 5 junior, we have 4 junior students, and out of 4 we need to select 2 of them. Alright, so now we need to simplify. 5 combination 4, it's 5, right? And 4 combination 2, it's 6. So 6 plus 5, it's 30, and 80 plus 30 leads to 110, and that is your final answer. Alright, so such type of questions are quite critical, and you need to read between the line very importantly. You need to highlight the condition. Now the condition here that is very important is at most. You must understand the meaning of at least and at most. At most means that you have given the maximum value, right? If it says at most one of the cousins, that means this is the maximum value, right? Either one of them is included or none of them will be included. That is the meaning of at most. And for at least, which is exactly the opposite of at most, in which we consider if it says at least one, that means it is minimum one, or maximum it can be more than one. Alright, so these are the very important keywords that you need to really focus while attempting any past paper question. Alright, so I hope that it is clear to you, and as a homework you need to attempt question number 5. I am pasting here because maybe mostly of you don't have the books. So you need to attempt question number 5 as your homework. Alright, and I have pasted the answers as well, so you can verify your working. So give it a try and make sure that you are reading the question carefully, highlighting the conditions which are really important for your question. Make sure that if you read the question carefully, if you highlight the given condition, so the chances are very bright that you will end up the right solution. That is why I keep emphasizing for the first lecture that you need to read the question carefully. Alright class, so I think that is quite enough for today class. Inshallah in next class we are going to continue with the past paper question. Till then, take care and Allah Hafiz.